Hello friends, in our last video we defined circle as the collection of points which are at a fixed distance from a fixed point. And the fixed point is known as the center of the circle and the fixed distance is known as the radius of the circle. In this video, let's explore some more terms related to circles. We said that a circle is a collection of points. Now, consider 2 points P and Q on the circle. If we join these 2 points, we get the line segment PQ. Now, this line segment PQ is known as the chord of the circle. So, we can define a chord of the circle as the line segment joining 2 points on the circle. Now, here is an interesting question for you. How many chords can be drawn in a circle? Infinite, right? We can draw as many chords as we want in a circle. Since there are infinite points on the circle, we can draw infinite number of chords. Now, there is a special type of chord. If a chord passes through the center of the circle, then that chord has a special name and it is known as the diameter of the circle. Here, we can see that the line segment AB passes through the center of the circle, which implies that AB is the diameter of this circle. Now, here is a question for you. How many diameters can be drawn in a circle? Infinite, right? We can draw as many chords as we want passing through the center of the circle. So, we can conclude that there are infinite number of diameters in a circle. From this, we can also conclude that infinite number of chords can be drawn passing through a particular point in the circle. So, there are infinite number of diameters as well as infinite number of chords passing through a particular point in the circle. Now, here is a circle with the center O and PQ is the chord in this circle. By drawing the chord PQ, we have divided the circle into 2 portions. One is this and the other one is this. Now we say that both these pieces are known as the arcs of the circle. Putting this in words, we can define an arc as the piece of circle between 2 points. Remember that only this circumference is known as the circle, not this region. This region is known as the interior of the circle. So, here we have 2 arcs. One arc is longer and the other arc is shorter. We call the longer arc as the major arc and the shorter arc as the minor arc of the circle. Now, let's see how we can represent these arcs. Let's plot 2 points A and B on the circle. Now, PAQ is the minor arc and is represented by PAQ with an arc on top, and PBQ is the major arc and it is represented by PBQ with an arc on top. This is the symbol used to represent the arcs. If you observe carefully, the chord of a circle even divides the interior of the circle into 2 regions. Now, each region is known as the segment. That is, the region between a chord and either of its arcs is known as the segment of the circle. In the same way as we have a minor and a major arc, we also have minor and major segments. Now, what is the minor segment? It's very simple, right? We can understand from the name itself. The region between the chord and the minor arc is known as the minor segment of the circle. What about the major segment? The region between the chord and the major arc of the circle is known as the major segment of the circle. So, we have understood minor and major arcs and minor and major segments. Now, let's explore one more term related to circles. To understand that, let's consider a circle with the center O. And A and B are the points on the circle. Let's join OA and OB. Now we have formed a region which is between the 2 radii OA and OB and between the arc AB. Now, can we call this region a segment of the circle? No, right? This region is not a segment, since we know that a segment is a region between the chord and the arc of a circle. But here, this region is formed between the two radii and the arc of the circle. So this region is not a segment of the circle. Now, what is this region known as? Here, we will introduce the new term sector. The region between the arc and the two radii joining the center to the endpoints of the arc is known as the sector of the circle. Even here, we have two sectors, minor sector and the major sector. The sector on the minor arc is known as the minor sector of the circle, and the sector on the major arc is known as the major sector of the circle. So friends, I hope you have understood all these terms in a circle. Now, here is a circle with the center O and the chord BC. Now you have to identify the arcs, segments and the sectors in this circle. Pause your screen and find them. So, in this circle, BQC is the minor arc and BPC is the major arc. The red colored region is the minor segment and the blue colored region is the major segment. To find the sectors of this circle, we have to join the center of the circle and the endpoints of the arc. So let's join O and B and O and C. Now, the region in pink color represents the minor sector and the region in the yellow color represents the major sector. This time, observe the radius and the diameter carefully. Can we form a relation between them? If you observe carefully, AB is the diameter and OA and OB are the radii. Clearly, all the points O, A, B are on the same line segment. So, from the Euclid's postulate, we can conclude that AB will be equal to OA plus OB. Now, let's say the radius is R units. Now, what will be the length of the diameter? Now, the length of the diameter AB is equal to the length of OA plus OB, which is nothing but 2R units. So we can conclude that the length of the diameter is equal to 2R units, which implies that in a circle, the length of the diameter will be twice the radius. In other words, the radius will be half the length of the diameter. So friends, that's all for today. I hope you understood all these terms related to circles. In our next video, let's learn a new concept related to circles. As of now, let's summarize what we have learned so far. A line segment joining 2 points on a circle is known as the chord of the circle. If the chord passes through the center of the circle, then that chord is known as the diameter of the circle. Infinite number of diameters can be drawn in a circle. Infinite number of chords passing through a particular point can be drawn in a circle. The length of the diameter is twice the radius. A piece of a circle between 2 points is known as the arc of the circle. The region between a chord and an arc is known as the segment of the circle. The region between the arc and the 2 radii joining the center to the endpoints of the arc is known as the sector of the circle.